Hi, I'm Mark Wheeler, the Commercial Director and part owner of the Guardtech Group, and I'm here today to discuss the fundamental principles of cleanroom design. This presentation is to support those of you that are looking to construct a new controlled environment within a new or existing facility. I'm here to share a wealth of knowledge accumulated over the past 20 years, obviously in a heavily condensed fashion, on the best way to scope out a successful cleanroom project, including key design considerations and implementing a framework that will give you the greatest chance of delivering a fully thought through project. So let's start at the very beginning, defining the reason for needing a cleanroom, which ultimately lies with your product and process, and essentially asking a series of fundamentally crucial questions to facilitate the design development. Any good project starts with an incredibly clear, well-considered and appropriately challenged brief. And one industry really leads the way as the example of best practice for this approach, the pharmaceutical industry. Pharmaceutical environments start their life as a URS, or a user requirements specification, which is a document that's been compiled and influenced by a number of key stakeholders within the business to map out an extensive set of requirements and performance criteria that must be met in order to determine project success. This document is well structured, heavily formalised, includes a sign-off and approval process, and often has been reviewed by appropriate and experienced external consultants that understand specific regulatory demands and can positively influence the content to ensure essential and important points are included. A good URS focuses on the broader performance outcomes rather than defining individual material specification, and leaves sufficient room for a range of alternative methods to be employed by the construction contractor. A common trap is compiling a URS from downloaded templates or previous projects, which can lead to demands that may be irrelevant for the current project, resulting in unnecessary build costs, whilst other highly relevant points may not be properly factored in. So the starting point to any design is assembling your ideal project team right from project inception and committing to developing your detailed brief or URS. And here are a number of questions and thoughts that you may want to consider as you begin to form and develop your cleanroom brief. Performance specification and room data sheets. Determining and recording required rooms and their associated dimensions, internal heights, classification, temperature and relative humidity levels with specified tolerances, required lux and acceptable noise levels. This part of the brief should be focused on everything that you want the environment to achieve in each of its specified zones. Process flow. Outlining clearly what happens in the space and how it happens. How do the personnel enter and leave? How do they move around the process in the most efficient manner? How do raw materials enter the space? What is the route for finished goods? How is waste collected? How are all of these things done in a manner that minimises cross-contamination opportunity? What tools can we use to minimise this risk? Transfer hatches, trolleys, HEPA-filtered good lifts, cranes. This all needs planning and documenting within process flow diagrams and schematics. And all of our decisions need to be focused on reducing movement and restricting entry to our most highly classified zones. Equipment register and general arrangements. A list of the equipment that you're using and to scale representation within your layout drawings. The dimensions and a consideration of how kit transfers into, and importantly throughout the space for initial installation, considering turning circles and access points, doorway widths and heights, and potentially removable access panels. The maintenance access that's required for the kit and the clear space required around the equipment for suitable ventilation and effective operation. Utility schedule. Following on from the equipment register, defining a full utility schedule for each piece of equipment. What power is required to the kit? Does it require gas services such as nitrogen, compressed air, vacuum or extraction? And defining the associated flow rates. Is water or drainage required? What is the likely heat output so that we can factor this into the air conditioning design to compensate for the heat gains and meet the overall room condition? Personnel. The people required to run the process, determining the occupancy for each process room and outlining the likely shift pattern, thus dictating the space required for the change area to facilitate appropriate occupancy levels whilst considering switchover of operators. Product considerations. What environmental conditions does the product require whilst in production and during storage? Is it sensitive to changes in temperature, to low or high humidity conditions? Do vibration levels need to be considered? Lighting levels in terms of luminance or wavelength? Is the product vulnerable to or does it generate a static charge? These are all essential considerations that need to form definition within your requirement. Regulatory compliance. Is your product regulated by a governing body such as the MHRA, the FDA, World Health Organization or NADCAP? And if so, what guidance do you need to review, understand, consider or follow? such as EU GMP guidelines, Eudril-X Volume 4 Annex 1, and to what extent you choose to acknowledge the guidance provided by the full range of the ISO 14644 standards, and how does that govern your brief? Construction principles. How do you want your facility to be built? Would you rather the more traditional stick-built approach of on-site construction, or are you tempted to adopt a more modern approach with off-site pre-constructed pods or modules that are delivered to site in a more plug-and-play fashion? If this is the case, will those pods be installed internally within a shell, or will they be external units that need to be weather resistant? Host building. What limitations or restrictions are you presented with by the selection of your host building for the project? And are those limitations that need to be accommodated or overcome? Floor space available. An internal height of the building will determine whether it's a single or a multi-storey cleanroom, whilst considering the need for plant space above the cleanroom ceiling, usually a minimum of 800mm. Is the concrete floor slab fully cured, or does it need a DPM to seal from moisture leaching? Will the building structure form part of the support strategy for the cleanroom and its infrastructure, or does it need to be a freestanding environment with independent steel portal frame to suspend from, or indeed a mezzanine serving the same purpose, whilst providing additional space for potential utilisation above? Does the building have sufficient electrical capacity to support all the process equipment and the cleanroom plant that you plan to impose? Has an electrical register been composed to determine the full load? Does an upgrade need to be factored in, as this will likely add up to 20 weeks to the delivery schedule? Is there appropriate access routes to get all components into the building and delivered to the specified space? Is there facilities on site for contractor welfare, or will this need to be included within any project costs? Is there sufficient water and drainage, and can these be incorporated without running water services over the controlled environment? Health and safety. Offset against the functionality of the process is the legislative and ethical demands of the facility, and ensuring that your environment is compliant with building regulations and safe for operation. Developing a fire strategy and planning appropriate escape routes, determining the fire rating of the structure, deciding on the fire suppression strategy, such as sprinklers or other aspiration systems, smoke detection, and whether this is also required within void spaces. Access control and door interlocks, and the appropriate override systems in the event of an emergency. Considering power outages and ensuring your escape strategy factors this in. Electronically powered rapid rise doors need particular attention here. Tying into your HVAC and filtration systems to the fire alarm to shut down critical systems in the event of a fire, and accommodating false alarms within a double knock system. Considering lone working and utilising CCTV or appropriately placed vision panels, whilst also considering privacy for changing facilities, accommodating intercoms or other communication methods. Redundancy and future-proofing. Has the design fully considered the potential future expansion plans of the business? And does it facilitate possible extension or even upgrade, such as potentially moving up classification to accommodate new, more tightly controlled products? Is relocation a prospect? If so, this should be considered with the material selection process, with a focus on ensuring that as much of the installation materials can be retained and relocated. Has appropriate consideration been given to redundancy within the mechanical and electrical plant? Could the business afford for an air handling unit to go down, or does an N+1 strategy need adopting to ensure continuous operation? Is a UPS required or a generator to offset the risk of potential power cuts or outages? Energy management and environmental impact. Outlining the corporate objectives early on for carbon reduction and environmental impact is essential, as it will lead to only restricted materials being considered. This is especially prevalent in materials such as refrigerants, gases, and insulation types. This focus may very well also impact the strategy adopted for air handling and management. A forward forecast and review of the potential ongoing energy costs may also lead to decisions on more efficient and likely more expensive air handling equipment being selected, as a relatively quick return on investment may justify the upfront capital costs. Setback modes during periods out of operation and intelligent control systems that adjust demand based on set parameters such as particle counts can also be accommodated within this assessment. Cleanability. Reducing ledges and corners wherever possible to reduce particulate settlement. Introducing materials such as coving to make surfaces continuous. Ensuring that all materials selected are cleanable and also are compatible with the cleaning regime and materials selected for facility decontamination. And incorporating specific plants such as centralised vacuum systems to move exhaust air from clean spaces to unclassified plant areas. And lastly, project prioritisation. We refer to this as the golden triangle. Timeline, budget, quality. It's essential for project success that you determine the priority of these three outputs and how they are balanced to deliver the design required for your specific construction project. You can never achieve the highest quality environment for the lowest price delivered in the quickest time. So deciding exactly where the project sits within the triangle will help determine the design options that are selected. So as you can see, there are a wealth of questions that need tackling when pulling a complete and well-considered design together. And the answers lie with those that are closest to the process and the objectives of the business. As always, the devil is in the detail, and a design that delves as deeply as this will result in a construction project that's well informed and a controlled environment that is truly suitable for its process. I hope that this has been useful to you, and I wish you the very best of luck in designing and constructing your future cleanroom. Perhaps our paths will cross in the future. Thanks very much for listening, and keep it clean.